Hey there, this is lesson 2.3. We're going to link rate of change and slope together. So one of the things that we're going to ponder today, I wonder how rate of change is related to the slope. And I wonder, how do I determine from slope when I'm given a graph, when I'm given 2 points, when I'm given an equation in standard form, and when I'm given an equation in slope-intercept form. So let's get started figuring out these things. Ready? Here we go. Lots of vocabulary. This chapter's full of it. So independent variable. That's the variable that goes across the x-axis down here, independent variable. You could think of it as when you're evaluating, that's the variable you plug a number into and it becomes the x-coordinate of an ordered pair. The dependent variable is the variable that goes along the y-axis. Okay, it's the y's in an ordered pair, and you can think of it as the value that's being calculated. Rate of change is another name for slope, really, because it measures how much the dependent variable changes compared to the independent variable. So we like to say the rate of change is the change in y divided by the change in x. And mathematicians like to get fancy, and they like to say delta y for change in y over delta x. Delta y over delta x. It means the change in y divided by the change in x. Okay. All right. Another term that we want to be able to use correctly is average rate of change. Average rate of change is slope calculated across time periods where things don't move consistently. So the graph is not a straight line, and so the rate of change is different for different time periods. Okay, so we can make the same calculation, delta y over delta x, but instead of it being a constant rate of change, which we're going to talk about in a moment, it's just an average. So if I were to look at the time period from 2 years, I'm going to change my pen here, from 2 years to 4 years, all right, that the slope of the line connecting those points would be different than the slope of the line connecting these 2 points. Both of those would represent an average rate of change, and they would be different because the time frame is different. Okay, so if we wanted to calculate the average rate of change between year 2 and year 8, we would do delta y, change in y, over delta x. So we would have 10 minus 5 over 8 minus 2. And then we would say it has a rate of change of 5 over 6. So my y changes like 5. In this case, we could probably say maybe it's 5,000. 5,000 students. It increased 5,000 students over 6 years. Okay, so that would be the average rate of change. Another rate of change is constant rate of change, and this occurs when you have a graph that is a straight line graph. And the cool thing about this is, like, the rate of change is exactly the same anywhere on the graph. No matter what 2 points you pick, you're going to get the same rate of change. It's a constant rate of change. So if we were to pick this point here, let's just call this 2 and 5, and then we pick 6, 9. We can calculate the slope. We would go 9 minus 5, that's the delta y, over delta x, change in y over change in x, over 6 minus 2, we would get 4 over 4, and that would be equal to 1, okay? So let's try a few of these. The first one is a table of values. And so you just kind of want to go and check and make sure that you do have a constant rate of change, meaning your x's are changing in equal increments and your y's are changing in equal increments. So if I go 2 minus 4, my change in x is 2. If I go 6 minus 4, this gives me a 2. 8 minus 6, that changes 2. 10 minus 8, that changes 2. So my delta x is equal to 2, right? My delta y, well, 24 minus 12, that's 12. 36 minus 24, that's 12. 48 minus 36, that's 12. 50, oh, that should be 60. Let's change that to a 60. 60 minus 48, that's 12. So my delta y is equal to 12. To find the slope, I take my change in y, delta y, 12, divide it by my delta x, 2, and I get 6 over 1. Now, on this graph, you can see that we don't have a straight line. Our segments kind of go cattywampus, right? Some are steeper than others, so we don't have a constant rate of change. We'll be figuring our average rate of change. The graph represents the number of digital cameras sold in recent years, namely 2004, 2006, 2008, 2010, 2012. Find the average rate of change of the number of digital cameras sold. All right, so I'm going to pick 2 points on here. I'm going to pick year 2004. Notice that I just wrote it as a 4, okay? And then that was 20,000 units sold, okay? And then year 9 in 2009, 80,000 units were sold. So my delta y is going to be 80 minus 20. That's my change in y. I'm going to go over here. Change in y equals 80 minus 20. And my change in x is equal to 9 minus 5. So I'm going to get 60 over 4. And 60 over 4, that's going to be 15. Oops, this should be a 4 here. And this should be a 5. My bad. And so that gives us a rate of change of an increase of 12,000 cameras sold per 1 year. Okay, that's average rate of change. If we are just given a random graph, we can just pick any 2 points on that line and use the slope formula. y2 minus y1, that's delta y. And x2 minus x1, that's delta x. So we're doing the exact same thing. This is the point 115. And this is the point 640. And so we'll plug those points in. So I get 40 minus 15 over 6 minus 1. And that gives me 25 over 5, or my slope is equal to 5, or 5 over 1. Simple as that. So if we're just given 2 random points, not even on a graph, we just have 2 ordered pairs. My suggestion to keep things straight and orderly, label the first one x1, y1. Label the second one x2, y2. And plug it into our formula for slope. This is the same as delta y over delta x. That's a delta. All right? And then when we're done, we're going to simplify our fraction. So I get 12 minus 2 over 8 minus 3 gives me 10 over 5. So my slope is equal to 2 or 2 over 1. All right, we simplified the fraction, and that's that. How about if we're given an equation and it's in standard form? Okay, you could take your equation and you could solve for y, getting it in slope-intercept form. You could do that for any of them, but I want to show you a shortcut, and I'm actually going to put this equation, ax plus by equals c, I'm going to convert it into slope-intercept form so that we can figure out how to quickly calculate our slope without putting it in slope-intercept form. So I'm going to subtract ax from both sides, and I get by is equal to negative ax plus c. Now I have to divide through by my coefficient b, and I get y is equal to the opposite of coefficient a over the coefficient b, x, plus c over b. This is my slope. So when we're in standard form, we don't have to go through all of this and this. We can just do slope is the opposite of the coefficient a divided by the coefficient b. Remember to pick up the appropriate signs. So in this one, I have m is equal to the opposite of coefficient a divided by the coefficient b, and I get the opposite of 3 divided by, this is b, negative 6, and that gives me a positive 1/2, just like that. My slope is a positive 1/2, and I didn't have to solve for y. I could just pick it off really quick. This is a super handy thing to remember. You want to remember that. Let's try it with this one. So I'm in standard form, so I know that my slope is the opposite of coefficient a divided by coefficient b. So that gives me 4 divided by 1/2. I'm going to write it as a fraction because I know that when I divide by a fraction, it's the same as multiplying by its reciprocal. So that means it's 8. My slope is equal to 8. If you wanted to hit pause, you could go ahead and put this equation in slope-intercept form and convince yourself that the slope is actually 8 if you don't trust the process. It's fancy and it's fast, so you should try and use it. Then we're going to determine the slope from an equation in slope-intercept form. So you just have to be careful that y has a coefficient of 1. All right, you don't want any number other than 1. You don't want negative 1. You only want 1. And then when that happens, the coefficient of x is your slope. So let's use this equation here. Negative 6y equals negative 3x plus 12. I'm going to isolate y by dividing everything through by negative 6. And I get y is equal to 1/2 x minus 2, and this is my slope. M is equal to 1/2. Getting close to the end. This is kind of a fun little game to play. We're going to find a coordinate when we know 3 of the 4 coordinates and we know the slope. This is like working backwards. So you know the slope, you know one complete coordinate, and you know part of another coordinate, and you're looking for r. So we're just going to plug in and then solve for r. So I'm going to work this way first. So I get negative 3 minus r over 4 minus 10, and that has to equal 2. So I might move this around a little bit. So I have 2 equals negative 3 minus r over negative 6. All right, that's 4 minus 10. Notice that I put m is 2, so I put that in for my m value. Now I'm going to multiply both sides by negative 6. And so I get negative 12 is equal to negative 3 minus r. I'm going to add 3, so that gives me negative 9 is equal to negative r, or 9 is equal to r, just like that. Those are kind of fun. All right, so these are the problems that we're going to work on in class. I know you got this. This should be super familiar. Thanks for listening, and I will see you tomorrow.